Hello, everyone, and thank you for joining this week or this month's web series as part of webinars, Praxis webinar series about managing test data nightmare with Andy or Andrew Knight. I'll let him introduce himself in a little bit. For those of you who are not familiar with Praxis, I'd like to take a minute and to tell you a little bit about who we are. My name is Noah. I'm part of the Praxis marketing team. A little bit about what Praxis is and what we do. So we'll be in the loop in case you haven't heard of us, and we would like to change that. So Praxis is an end-to-end enterprise-grade test management platform that's powered by QA intelligence and AI. We're a centralized hub, essentially connecting any type of testing from any platform that you work with into one repository in order to help you make better testing decisions and deliver better quality software. We are, of course, compliant with all the relevant certification that's needed, ISO, SOC, GDPR, you name it, and we are a leader with G2. You can check it out on their website as well. What we're trying to do, essentially, our uniqueness is about our ability, been around since 2008, so quite some time around. If you don't know us now would be a good time. And essentially, our platform is unique in its way to take complex testing, any type of testing, and to untangling its complexity, allowing you seamless control into your testing process, superior QA intelligence, as I mentioned, some powered by AI, but not just. And then some of our customers, so you can see we have hundreds of customers across the globe, basically from any industry. Some of the names you might be familiar, but some, if not, there are many more which are not listed around here. So that's just about it. If you're not familiar with Praxis, two options. One, you're more than welcome to reply to the recording of this session, which will be shared and ask for a dedicated demo. And additionally, we have a live training and Q&A session if you prefer not to commit or just want to play around with other members. Twice a month, we have a live training session, the next one coming up next week on March 27th. So we invite you to join that session as well. And one last thing before I hand over to Andy is about our next month webinar, which is planned, is a roundtable session discussing the state of testing report. This is a survey that we have been providing since 2013. So this year is the 11th edition. If you haven't read the survey, we invite you to go into our website and download the survey. It's of course free, needless to say, and we invite you to join the discussion, joined by Joel Mifaliski, which is Praxis co-founder, Lalit Purav, Gite, and Erica. All of them are leaders from the QA arena. If you don't know them, that's also a great opportunity to hear them out and ask them questions live. Of course, for that, we will share the recording as well. And without further ado, Andy, the floor is yours. Maybe if you can say a few words about yourself.
Sure thing. Hello, everyone. And thank you so much, Noah. And thank you for Praxis for inviting me to give this webinar. As I said, my name is Pandy Knight. I am the Automation Panda. Should I share my slides now?
Yes, you may. I wanted to share. I wasn't sure if it's okay that I will introduce you as Pandy, but that was one option that was debatable. So handing over to you.
Great. Thank you so much. All right. So I am the Automation Panda. I've been doing software testing and quality and automation and BDD and even some development for, gosh, a long time now. Currently, I am the principal architect at a company called Cycle Labs based in Raleigh, North Carolina in the wonderful United States of America, where we are building an end-to-end test automation platform that targets enterprise software, specifically in supply chain and warehouse management solutions. Be sure to read my blog at automationpanda.com. Be sure to follow me on Twitter or X or whatever it's called now at Automation Panda. Connect with me on LinkedIn as well. So one of the toughest challenges in testing any software product is handling the test data. Now, when I say test data, I'm referring to multiple things. Test data includes both the actual data inside the product under test, as well as the data values used by test cases. As testers, whether we are testers by role traditionally, or we are some other kind of engineer that comes in and takes on testing responsibilities, we shouldn't underestimate the work to handle data properly. Good test data is just as important as good test cases and good automation. So today in this webinar, we'll dive deep into the connection between product data and test case data. We will learn how to pick the right strategies for handling both, including how to avoid data collisions when testing. And by the end of this webinar, you'll know how to manage the test data nightmare for your own test projects. Whether you're testing, let's say, a React app, some sort of Python project, something else entirely. So let's learn together. Let's say we have an application for a bank to provide loans. The bank could configure this application for many different types of loans, such as a home mortgage, a car purchase, or a student loan. All the information the bank needs to provide loans must be stored as data in the system. Each loan product is different. It comes with its own maturity, rate, payment schedule, you know. The bank must also store information about the borrowers, funding curves, profitability targets for these loan opportunities. It's pretty complicated. I've worked in banking software spaces. Wow. If you have to put it in the chat, I'd love to hear your horror stories. Anyway, testing requires all that data to be already present in the system as a prerequisite, or you can do the testing. We could write a simple test case to exercise the basic application behavior. Scenario: create a new loan application. Given the Chrome browser is open, and the page for myloanapp.com is loaded, when the user creates a new loan application for a home mortgage, and the user enters all their personal information, and the user submits the application, then the page displays a success message with a reference number, and the loan application is sent to the bank. Now, bear in mind, a real loan application would probably need several pages of information. But let's keep our example simple. This test creates and submits a new home mortgage loan application on behalf of the user. There are many test data points in this short scenario. Most apparently, there is all the user's personal information. There's the type of loan. There's also the record of the loan application sent to the bank, and the reference number shown to the user. Furthermore, the URL is configuration information, and the browser type is a test input. Test data is everywhere in this short, simple scenario. The data is inextricable from the test. Without specific data, this test would be meaningless. Unfortunately, the term test data is ambiguous. We've applied it to both the product data in the Loan web app, as well as to various pieces of test case data that make even the most basic test work. Product data refers to real data living in the software system. For the Loan web app, product data includes all the bank's product configurations and lending information. Test case data refers to data used to define test cases. It may include values to enter into the product under test, inputs to control how testing is performed, or records to retrieve from the product. In the latter case, test case data is a reflection of product data. Its values refer to entities existing in the product data. The two types of test data are separate but connected. Distinguishing these two types of data is important to avoid collisions. The dependency of test case data on product data can be brittle. For example, consider our test case step to create a new loan application for a home mortgage. This step works as long as the bank's application is configured for home mortgages. However, the product data could be changed at any time, just like product code. What if the specifics of a home mortgage application change? What if the loan is no longer called a home mortgage, but a personal residential loan? Even though a simple change in string name could make a test case break. Compounding breakages cause nightmares for test management. So, how should we manage test data? For feature testing, test data is just as important as test cases and test code. How do we handle both product data and test case data? Are there strategies we can use to avoid brittle dependencies? So let's explore multiple ways to handle both product data and test case data. There is no universal or perfect solution to the test data problem, but you can avoid nightmares by picking strategies that work well for your needs. Let's start with product data. As previously stated, product data is any live data in the product or system under test. In simplest terms, it's everything in the database. Examples of product data include things like user accounts, administration settings, product customizations, records created by users, and files uploaded by users. For our example loan app, product data would include user accounts, loan product settings, loan applications, and all that behind the scenes bank data like funding curves. Data must be present in the system as a prerequisite for most testing. And there are two primary ways to get that data into the system. On one hand, you can set up data before tests run. So it'd be static data creation. For example, the loan web app could be set up with a set of pre-registered users and a collection of loan types. Test cases, whether they are manual or automated, can presume that this static data is already in the system and simply reference it. Static data preparation is a good strategy for complicated data or data that is slow to create dynamically. For instance, user accounts may need email verification, so it might be easier for automated tests to simply use a set of pre-registered users. Tests will run faster if they can simply reference existing data instead of creating new data each time. However, static data must be maintained. Any changes to static data could impact tests too. Static data may also become stale over time as data formats are updated or if data is time sensitive. On the other hand, you could set up data during test execution. This would be dynamic data creation. In the example loan test case, the loan application document is dynamically created. The test does not reference an existing loan application. It creates a new one. Dynamically created records avoid the brittleness of hard references to static data. It can also be used exclusively by the current test case, protecting them from interruptions by other test cases or rogue users on these systems. The main downside of dynamic data prep is the execution time. It slows down tests. Dynamically created data is essentially disposable too, so at some point it should be cleaned up. Which strategy is best? Typically, testing requires both strategies together. Data that is slow to set up or considered immutable should use static preparation, while data that is quick and easy to set up should use dynamic preparation. When I develop test solutions, I prefer to create as much data as possible dynamically per test case to preserve test case independence. When a test creates the data it needs dynamically, it will likely be the only test using that data, and there's a much lower risk of test collisions. These two data prep strategies are a bit complicated when implementing. Dynamic prep depends directly upon the test cases using it. So in those cases, it's really contextual in what the test is trying to do. However, static prep does have a few general strategies that are independent of the test cases. So we can look at those together. The simplest data prep strategy for static data is manual configuration. That's exactly what it sounds like. Testers log into the system and manually create whatever records need to be in the system. This could be things like creating users, configuring settings, and saving records. The nice thing about manual configuration is that it's low tech. Anyone can do it. It does not scale well unfortunately, it does not scale well for larger systems because it is rather slow. Furthermore, manually configured systems can easily fall into disrepair without any automated mechanisms for maintenance. A better strategy might be automated configuration. Rather than manually setting everything up, automated tools can create the desired data. This could be accomplished in many ways. You could call the APIs, you could do direct SQL injections into your database, you could reuse UI interactions for traversing your system, or you could use config tools like Puppet or Chef. Automation could generate data deterministically or randomly, depending on your needs. The main benefit of automation is the ability to create fresh data at any time. Automation can also clean data, like scrubbing private fields or updating time-sensitive fields. Unfortunately, automated configuration is not a free lunch. It requires extra skills, and code must be maintained. If you want a shortcut, you could try to clone your databases. Cloning databases is easier than ever with cloud management tools. You can maintain one database in a golden state, or even in like a golden container, and then create a copy before every test run. Once testing is complete, the copy could be deleted or just deactivated. Granular cleanup would not be necessary in this case. Database clones make it easy to copy all the data at once without worrying about any damage that rogue testing could cause. However, databases can have a lot of data. We're talking gigabytes of data. So cloning large ones may not be practical. Cloning may also need extra refinement to scrub special fields and hook them up properly. Finally, if managing real data is too much of a hassle, then you could mock endpoints. This would completely remove dependencies on databases and even services. All data returned by the mocks would be deterministic too, so you could yield consistent results. However, mocks are not always a good solution. They often require a lot of effort to set up, and mock data can make the tests overlook unpredicted real-world variations. Mocks also mean that tests will not truly be end-to-end in coverage. These strategies can also work together. For example, you could use automated scripts to configure product data in a golden database, and then you could make clones of that database. In another example, in a large testing environment, you would choose to mock some endpoints while using real data for others. Many times we want to use production or production-like data in our systems to mirror the real world. Unfortunately, production data has personally identifiable information in it. It's not safe to share, and many things like credit card numbers and social security numbers must be kept private. Generating data synthetically is a great way to avoid these roadblocks. You can use synthetic data with any of these static data prep strategies. There are multiple factors that should be considered when deciding the best strategy for static data prep. Number one, how big is the data? If it's small, the manual configuration is probably sufficient. But if it's large, you need something automated. How fresh does the data need to be? You're going to need automation if data is time sensitive so that you can keep it up to date. How frequently will the data need to be updated? Again, automation can help for frequent updates. And this is also an area where synthetic data generation tools really shine. How difficult will it be to try advanced tricks like mocking or cloning databases? This might be especially difficult for old legacy systems. Warning. Is there any bureaucracy in the way of automated solutions? Hey, it happens. Every organization is different. Bureaucracy can stonewall advanced solutions that need extra support. Do folks have the skills required for automation or for database administration or containers or mocks? Skill level may be a barrier at first, but training and learning can help the team overcome any limitations here. And finally, what about the cost? Each data prep strategy has a cost. Teams should do a cost-benefit analysis when deciding which strategy to take. So that's how to handle product data. What about test case data? Let's look at that next. Test case data is inherently part of test cases. So let's revisit our example test case from earlier. As we saw before, there are multiple bits of test data throughout the steps of this short scenario. They represent different types of test case data. First, let's look at the first step. Given the Chrome browser is open. Now, the Chrome browser is test data because it specifies the type of web browser in which to load the web application. This is what we call a test control input. It directs how tests will be run rather than specifying feature behavior. Theoretically, this test should run the same on any browser type, but the steps dictate that the test should run on Chrome. As a recommended practice, test control inputs should not be hard-coded into the test automation code. Instead, they should be passed into automation as inputs. That way, tests can easily be retargeted. There are a few ways to do this. The simplest way would be to create a flat file with input values. I recommend using a format like JSON or YAML because they are easy to write, easy to read, and easy for programming languages to parse. They can also have line-by-line diffs. Test automation code can read the file before any test starts, and it can inject input values as appropriate. For example, using this JSON file, automation could read this browser type and construct, let's say, a Selenium WebDriver object for Chrome per test. The path for the input file would need to be hard-coded into the automation, but it could be as simple as a standard file name in a current directory. Another way to handle inputs is using environment variables. Testers could set variables from a system shell or profile, and automation could read those variables by name. This could be useful for integrations with continuous integration servers or Docker containers. However, it can be a little more dangerous because anyone could change variable values. Again, automation could read these variables before test run and handle them appropriately. Testers could store variables in .env files to make their values more durable. But note, with env files, variables cannot be hierarchical like JSON or YAML specs. So let's remove hard-coded step for browser type from the test scenario. That can be handled as an automation concern. Next, let's look at a second type of test case data. Notice how the URL is hard-coded here. This is also not good practice. Typically, development teams host multiple instances of products under development, like a developer environment or a staging environment or so on and so forth. Hard-coding configuration information like this limits where tests can run. Any information about a product's configuration is called configuration metadata. This can include things like URLs, usernames, passwords, and possibly other descriptors. There's a few ways to handle config metadata. You can use flat files or environment variables like for test control inputs. However, I recommend using some sort of flat file. And I also recommend separating test control inputs from config metadata. Create an input to refer to the target configuration and store multiple configurations in the config metadata files. That way, testers can change just a few simple inputs to target any configuration, and they won't need to change multiple configuration fields regularly. If you want to be fancy, you can store them in a cloud-based secret service like Azure Key Vault or Doppler. This would be especially helpful for keeping secrets like passwords safe. However, setting up such a service may be overkill for smaller projects. Either way, the test step can be rewritten to refer more generically to the web app. Automation can select the target environment using the inputs and config metadata. The remaining pieces of test case data all fall into a category called test case values. These values pertain directly to the behavior exercised by the test, not to any configuration factor. Even in this classification, there are subtypes. First kind of test case value is a literal value. These are values that are hard-coded in the test. In this example, the table of personal info contains literal values. Literals are simple to use, and they provide specification by example. Literals should also be independent of any statically created product data. They should be values that can be safely originated by the test case. The literals in this info table will be entered as input values into the web app directly. And theoretically, they could be any values. The second kind of test case value is an output reference. These are values that are retrieved from the product under test. Typically, they are the outputs generated by exercising a behavior. In this example test, the reference number can be scraped from the success page and verified for correct format. The loan application can be retrieved from the web app's backend to verify that it was submitted correctly. These values cannot be literals because they originate from the product. Tests must refer to them by reference and retrieve their values from the product. As a side note, this test dynamically creates the loan application. This would be an example of dynamic product data preparation that we covered earlier. The third and final kind of test case value is the trickiest, the input reference. At first, these may look like literals. However, input references are values that directly refer to product data. While personal info like name and address are created dynamically by the test case, the name of the loan type refers to the loan configuration in the web app. Thus, this test has an input dependency. It must specify the type of loan, here a home mortgage, and the loan type must already exist in the product data. The simplest way to write this test is to simply hard-code the reference, and that's what's done here. The name, home mortgage, refers to the name of a loan type in the web app. Automation can use that name when selecting the loan type from, let's say, a button or a dropdown or some API filter. Hard-coded references make it easy to write the tests, but they require statically prepped data to exist in the system. References also become hard to maintain when the product data changes, or when the same test must run against different configurations with different names. One way to avoid the pain of static data is to dynamically create these records and configurations. If, let's say, for example, the test calls the backend to create a new loan product named home mortgage for each test, then we don't need to worry about that static pre-prep. But we have already covered the pain points of dynamic prep. So in this case, let's say that dynamically creating the new loan type is too slow. A more robust solution could be data discovery. Let's say the target web app is already configured with multiple acceptable loan types. Instead of hard coding the name of the desired loan type, the test could describe the loan type and then use automation to search the web app's config to find a loan type matching the desired criteria. For example, if different regions of a bank have different names for this type of loan, the discovery mechanism could look in the configuration for a satisfactory home mortgage loan and return the specific name for the current bank region. Discovery enables tests to search existing product data for the required records instead of hard coding those records. Discovery makes tests more resilient to changes in product data. It's really good when testing multiple environments with ever so slightly different configurations. However, it does require an extra layer of coding, so it might be overkill for smaller projects. That's a lot of info about test case data. In summary, test control inputs direct how tests will be run, not what behavior is covered. They should be supplied via flat files or environment variables. Configuration metadata describe product configuration for the target environments. They should be supplied via config files or some sort of service API call. Test case values direct the behavior covered by the tests. They may be literals, output references, or input references. And input references may be hard-coded or discovered. At this point, you're probably thinking, wow, that's a ton of information. That's it, right? We're done. It's time for Q&A. Well, frightfully, the nightmare's not over quite yet. There's one more problem to address. Collisions. Collisions happen whenever multiple actors operate on a shared resource. For example, they could happen whenever multiple testers simultaneously access the system, or let's say when tests run in parallel if they're automated. We need to take additional considerations to avoid collisions. First and foremost, isolate your test environment. Please isolate your test environments. Prevent external actors from interrupting your tests. If you have a shared test environment, block other folks from accessing the system when the tests are running. You might need to schedule test off hours to make that happen. You might also want to set up multiple test environments. The product under test is containerized, or if your databases are clonable, you could easily create dynamic, fresh environments for each test launch. That would guarantee perfect isolation. Secondly, treat any shared test data as immutable. Sometimes shared product data is unavoidable. Like if you're running tests in parallel against one test environment, they could access the same product data. Or if an application has multiple components, certain components may be difficult to isolate for testing. So whenever data must be shared, treat that data as constant, as immutable, as something you don't change. Any changes to shared data could break tests. For example, one test might require a car loan, but another test might go into the system and delete the car loan type from the bank's configuration. Oops. Any tests that must alter shared data should be run serially instead of in parallel, and they should always undo any changes they make. Third and finally, use dynamic data prep as much as possible. Tests can't collide on data they don't share. Keep statically prepared product data to a minimum. Statically created data is more likely to become shared data, and shared data is more likely to cause collisions. Boom! We covered a lot of material in this past half hour. So let's recap what we learned. There are two primary types of test data: product data and test case data. Product data can be prepared statically or dynamically. Test case data either control how tests run or reflect product data. We should always handle references and share data very carefully. And overall, choose the best strategies to defeat your nightmares. Every product is different, and every team is different. You're going to have different needs that I can't even predict. So take these strategies as suggestions and advice from me to you, and choose which ones will work best for your needs. Thank you all so much for listening to my talk today about test data. Again, my name is Andy Knight, the Automation Panda. Be sure to check out my blog, follow me on social media, hit me up on LinkedIn. Be more than happy to connect after today's talk. So with that said, let's open up for questions and answers. All right, does anybody have any questions? Feel free to put them in the chat, to come off the mic and share. There's even a Q&A feature in Zoom, which is pretty cool. Nothing. Oh man. No questions. That's first. Not seeing anything in the chat. Oh, there's one. All right. So, question. Oh, okay. Mariah, I don't have any questions off the top of my head, but I want to say thank you. I've learned much and look forward to applying. Awesome. Glad to hear, Mariah. Cool. Any others? Oh, I see Noah's back. No, oh, here's a question. Okay, we've just been waiting for questions. So, Dharmendra asks, are there some tools to generate test data according to requirements? I think I might need a little more information before I could properly answer this question. There are plenty of test data generation tools out there in the market. They range from everything as simple as like fake data generators, if you put in a specific schema or database table, all the way up to there's a bunch of vendors who are creating very sophisticated synthetic data tools where they will look at, say, your database models, or I don't know if they would look at, say, like requirement documents, but if you can give it some sort of data schema or data structure, it can look at that and then generate data from that. Like, oh, you need 1,000 users entries into your database. You need 1,000 events. Yeah, and it'll just spin it up. And what's really nice about the synthetic data generator tools is that they try to be statistically accurate based on what is seen in production. So, like they'll look at existing data and they'll say, okay, well, we'll use more realistic names, more realistic formats, and we'll try to generate data that mimics the types of things in production versus just random fake data, which might not align. Great, good question. Awesome. Any other questions from our participants? Don't be shy, it's okay.
Hold on, I think I have one more question.
Okay.
The one question is about, is there ways that we can handle unpredictable data or data that is behind the control of my specific team coming in?
Ooh, now that is a good question. Unpredictable data, yes. So let me define what I would think of when I hear that word. I've been on teams before where we are working on very, very large systems, right? It's, many of us, especially if we're working at bigger companies, it's like you're not just building some little tiny React app, right? It's like there's this enormous application with multiple backend systems and services, and there might be, it's more like you've got this ecosystem that you're maintaining and building. And so when you're in a system like that, you may not be in full control of the data that comes into your parts of the system that you're building and testing, right? And so it could be that the data that comes in is rather unpredictable. right? It could be that it's almost like it seems random to you, right? You might have certain formats and structures for your data, but the frequency it comes in, the types of values in your fields, or it might just be completely unstructured data. It might be just like globs of JSON being hurled at you, and you have to kind of parse through and figure out what does this mean, right? That's what it means to have unpredictable data, where you are not in control of your data. Someone else is giving data to you, and you don't always have a clear notion about the structure or shape of what that data is. And so to handle that, I think tests need to be a little bit, or how can I say? The systems need to be defensive on what that kind of data is. It's like, you can't always shove the circle into the square peg, right? You have to be accommodating of anything. And when it comes to testing it, it's like, it can be really hard to predict what that unpredictable data would look like. And so some techniques you can do to handle that would be maybe try to sample some of the data coming in, and then capture that, scrub that, and then replay it for your tests. Be like, okay, well, here's really what production looks like to us. Let's gather up some of this, and then do it for so long or some amount, and then just grind through that, and you can have some decent confidence to say, okay, we've made the unpredictable more predictable. Or you could use those synthetic generation tools, right? That it can sample the data from that, get a feel of the structure of it, and then try to generate more data kind of like that. Could be a way help you, rather than you try to hard code it all yourself. You can use that as a launch point.
Thank you for this. And we have one follow-up. Actually, it's not a follow-up. Okay, actually,
oh, wow.
Yes, that raised up several questions. So one asked about the best way to handle test data from different environments where end-to-end tests are running in parallel, and specifically shared that they have different data based on each environment, staging, sandbox, production. So the question is how to set data sets which should be present in test cases based on environment where are running them. Probably something parameterization of data,
yeah,
data management, data staging, I would think, but handing to you, Pandy.
Sure. Yeah, no, it's very common that you would have different environments, like your staging, your production, your developer. I mean, sometimes be about multiple instances of each of these environments. So in this case, it can be tough, right? Because like one strategy is, well, let's just make sure we just put the same data into all the systems, right? It's like, okay, well, I've got this, either I go in as a human and I manually enter records in each one, or that I've got some sort of data dump, that I've got some script that I just kind of push into each of these environments. And then if you do that strategy, then you can you can hopefully trust that the data records are going to be the same across all the systems, so that you could write tests with, say, hard-coded references to particular records. That, however, I found in theory sounds great. In practice, breaks down, because there's always differences between these different environments, right? And I mean, it could be as simple a case of like, okay, well, we're adding a new feature, we're changing something, and it's currently in the developer environment, but it hasn't hit staging or production yet, right? And so it's like, you can't necessarily have the exact same data copies in all these environments, because you need something special for this one over here, this developer one. So in this case, it might make more sense that you would have some sort of data generation tools if you need it. And that way you would be editing not just the data directly, but more rather the script for generating the data. And then and it can either be a generation tool, or it can be like a copy from prod and bring it down and scrub it kind of thing. But moreover, if you're dealing with those different environments of ever so slightly differences between them, that's when you might want to look into a discovery strategy to say, hey, rather than saying I need record number 1, 2, 3, 4, 5 and hoping that record 1, 2, 3, 4, 5 exists there, that you could say, hey, I need to find a particular data object that meets certain characteristics. You know, like I need to find a user of the system who is over 65 years old, right? Why? Because Social Security or something. I don't know, right? Some arbitrary condition. And so what you can do is you can go to your users table and try to query on, okay, find me a user that has a birth date before 65 years ago, right? And that way you can make sure that you get a record of somebody that meets the criteria you need for testing. And so that can make your test data management and your test cases a little bit more resistant to the differences in changes. And so what happens is it's like if you find out in a particular environment you don't have any users over 65, okay, well now you know exactly what kinds of users to enter. And it doesn't need to be an exact user with a specific ID or specific name or something. It's just, let me go add a new user that has this particular criteria. Boom, done. And then you can add that to your maintenance scripts. So that's how I would handle, you know, data between different environments.
Thank you for this. And Andy may, yeah, I think I'm thanking you. And that was, I'm not sure why the chat was disabled for some people, but it's double thank you for this answer. And if we can still, the last question from your time was about a question that came from a specific project, from a specific client who was a live streaming channel. In which during testing, they asked not to upload any other channel data, like show names, metadata, video, and did not provide any data from their side. So there was, he shared his search video on YouTube and download them to local environment and use the test data. But would you have done it differently, or is it any other way? You know, to access data when you have limitation in regarding, you know, we all live in a world of power and privacy or just company regulation. So just your point about that.
Man, that kind of stinks. Like you've got a client who's like, do me this thing, but I'm not going to give you the thing you need to help you do it. Like, really? Like, what? I mean, I don't know the situations there. To me, that sounds like that there was a business problem involved more than a technical problem of like, hey, you know, in order for us to help you, you need to provide certain things. Like you need to provide at least the data formats that you need. If you've got some production data, you can scrub for us. That would be really helpful, right? So, but apart from that, let's say you're stuck in the situation. Like,
I'll argue you, Andy, that, you know, testing is a part of the business, and you have to find. You're not testing for the sake of testing. You're testing for the sake of successful businesses. So a business problem becomes a testing problem, and vice versa. Just not a technical problem.
Yeah. Absolutely, Noah. So yeah, I searched some videos on YouTube and downloaded them on my local and used that as test data. I mean, hey, sometimes like that's what you got to do. If you're not going to be given the test data, you've got to find it from somewhere. And so it's you fall back on things like, can I like manually put something together myself? Like if you only need small scale data, you know, maybe you could patch something together. Like right now, I'm working on a project where I'm building a test report dashboard. And so there are different events for when tests get completed. And so it's like, all right, well, I need to do my testing on the dashboard. I need to create certain events of a certain format. And so in some of my unit tests, I'm just, you know, manually coding up, here's this field, here's this value, here's this field. So that can do for small scale. If you have the data structure that you know you need to fit, you know, like you're given, okay, this is what the database table looks like, or here's the expected JSON schema for a particular request. There are data generator tools that you could basically feed in that specification and it'll spit out, you know, random fake data for you, or like those synthetic data tools I mentioned before. But honestly, that's what it comes down to. It's like, if you're not going to give me a test data set, I'm going to have to create it. And if I'm going to have to create it, either I do it with fingers on a keyboard, small scale, or I get some sort of data generation tool that takes and poops out more data. And I think the only extra thing I would do in that case, regardless of how the data is created, I would probably take some of that generated data or created data and share it with the client to be like, okay, does this data look like what what your system needs. Like, can you do a quick review of this? Is there anything that's missing? Right? Because sometimes you get tunnel vision and it's like you create data of a certain structure, certain format, but then there's something else you didn't notice or see. Right. So just to have that sanity check to be like, am I missing anything? That would be the only difference I do, Dharmendra.
Nice answer. Okay. I think I can speak on behalf of everyone. I can tell you I received a private message during your session, which contains the emoji of mind-blowing to describe the session. I think I'm going to speak in behalf of everyone and thank you for a very educating session. Thank you, Andy, for being with us. Thank you all for joining us today. We invite you to join our upcoming session, the next one about the state of testing or any other. We're having monthly webinars. Not all speakers are as nice as Andy, but I hope you can continue to learn some new stuff. Thank you all and have a good rest of the morning or rest of the day.
Thank you, everyone, for attending.